So here we are. Today we're talking about vector operations, and that is how do we mathematically treat our vectors. Oh, I'm typing a whole bunch of S's. That's fun. How do we mathematically treat our vectors? And what we're going to start with is talking about this airplane here. And I think you've been in probably enough math classes where you can visualize what's going on here. And you got an airplane, and this airplane's going to fly to the northeast. And the question is this the same mathematically as the plane flying to the east and to the north? And like I said, you've done enough math classes where you can say, well, gosh, look, I've got a line here and a line here. I went east and I went north. How can I figure out the displacement of my airplane if I know how far east and how far north? And you learn this wonderful tool. You've used it over and over again. This is nothing new. It's the Pythagorean theorem, a squared, b squared, c squared, where of course c is your hypotenuse. This is an excellent tool. If you struggle with Pythagorean theorem, make sure you're asking questions. I would be glad to help you with that, but that's all the time I'm spending on it. Aside from Pythagorean theorem, there's this other thing. And this is where your book can get a little goofy. It's the words. The words your book will say. The guy turns to the right of his forward path. Okay? What exactly does that mean? Well, let's use compass directions. Obviously, we have north, east, south, and west. Let's focus on this blue one. And clearly, the direction words are north and east. But the question is, we don't want to just say this is to the northeast because that's not specific enough. For say 25 degrees northeast, that doesn't help us. We have to decide, is this blue arrow on the east side of north or the north side of east? Go ahead, take a second. All right, hopefully you said this is on the north side of east, because here's east, go to the north of it, go to the north of east. So in the book, it'll say, north of east for 50 degrees or something. Okay, moving down to the purple. Obviously, we're talking about east and south here. So is this on the east side of south, the south side of east? Well, this is going to be on the south side of east. Here's east, go to the south of it. Over here, west and south. Is this line on the west side of south, the south side of west? And you look at it and you say, oh, that here's south, go to the west of it is the west side of south. So let's get rid of that one. West side of south. And then this last one. We've done this enough times. Obviously, you know what's right here. North and west. This is to the west side of north. The west side of north. Now, here's the good news. Let's say that you do everything else right in a problem, but you flip-flop this number. This triangle formed here with the north would be the same as a triangle you would incorrectly form here with the west. It would mean that your adjacents and your opposites will get flip-flopped. Okay, it's not the end of the world if you flip-flop those numbers. It'll throw off your answer, but it's not the end of the world. Moral of the story, show work. And then how do we solve said calculations? With this thing called SOHCAHTOA. Hopefully you know what this is. Sine is the opposite over the hypotenuse. Cosine adjacent over the hypotenuse. Tangent, we never use it. So sine and cosine, why is this adjacent? If this is the angle we are discussing, this line is right next to it. That's what adjacent means. If this is the angle we're discussing, then this is across from it, or the opposite side of the triangle. Again, if SOHCAHTOA is something you have struggled with in your math classes, talk to me. We will talk it out and we'll straighten you out real quick. It won't take very long. This is not a crazy concept for us to talk about. Okay? And that is how we do our vector operations. Now, if you're doing this live with class and you're working on some of the homeworks, you're going to have to be very careful about the shape of your drawings here. Hold on a second. Do I have the other screen available? Oh, that's the next assignment. This assignment's not that big a deal. Our next assignment, though, I'll need to show you these things. So we're all good.